Hello everyone, welcome to this next video on questions on integral equation. This question is from June 2012 consisting of 3 marks. The question is, for the linear integral equation, this is given to be our equation which is of Fredholm time because of this constant limits 0 to 1 by 2, right? The resolvent kernel are zeta, r, x, xi and 1 is which of these? So we need to tell what is the value of resolvent kernel for this given differential equation, right? So let us get started. The given equation is phi of x is equal to x plus integration from 0 to half phi of xi d xi, right? This is the Fredholm equation. And what is the value of resolvent kernel r x xi 1? This is equal to summation. M varies from 1 to infinity. What is lambda here? Lambda is 1. So 1 raised to power m minus 1 km x and xi. And what is this km x xi? This is the mth iterated kernel whose value is calculated as, let us see what is that, k1 of x xi, that is simply equal to the given kernel. What is the kernel in this case? In our question, the kernel kxt or kxi, that is equal to be 1 because here no term is given, right? So it is equal to 1. So let us see the next term, k2xi. By definition, this is equal to integration from 0 to 1 by 2 k of x into z, then k1 of z into xi dz. What is the value of kzx? This is simply equal to 1. No variables are included. So integration from 0 to half 1 into what is k1? It is again 1. So 1 into d of z. So that would simply be 1 by 2, right? Now let us calculate k3 of xi. What would be that? It is integration from 0 to half k of xz, then k2 of z xi dz, because what is the formula of iterated kernels? The mth iterated kernel, this is calculated as integration from a to b, whatever are the limits given in question. K of xz, here I am changing the variable by z, and it is km minus 1 z of z into xi of dz, and the integration here is with respect to this z. So this is the definition, right? So accordingly, what do we get? Here we'll have 0 to half, integration from 0 to half. What is its value? It is given to be 1. What is its value? Its value is half, and integration is with respect to dz, so it would be 1 by 2 raised to power 2, right? So let us calculate k4 x xi. So that would be integration from 1 to 2 k of xz, then k3 of z xi dz. So that would be integration from 0 to half 1 into 1 by 2 square dz. So that would simply be 1 by 2 raised to power 3, right? So can we generalize this in some way? Yes, we can. So what would be km xi? You see, k4 is equal to 1 by 2 raised to power 3. K3 is equal to 1 by 2 raised to power 2. K2 is equal to 1 by 2 raised to power 1. And K1 was 1 by 2 raised to power 0, right? So this would be 1. So I can generalize this 1 by 2 raised to power m minus 1. So this is my mth iterated kernel. So what is the value of resolvent kernel r, x, xi and 1? This is equal to summation, m varies from 1 to infinity. 1 raised to power m minus 1, which is simply 1, right? And this is 1 by 2 raised to power m minus 1. So let us solve this. This is this is equal to, when I put m is equal to 1, it would be 1 plus 1 by 2 plus 1 by 2 raised to power 2 plus 1 by 2 raised to power 3 plus so on. This is an infinite geometric series, right? Whose sum can be calculated because here the common ratio that is equal to 1 by 2 and whose mod is less than equal to 1. So its sum can be calculated, it is convergent. And how can we calculate that? It is given by the first term, that is 1 divided by 1 minus common ratio, that is 1 by 2. So that would be equal to 2. So the resolvent kernel here in this case is equal to 2. So option B is the correct option. The value of this resolvent kernel is equal to 2. That is it for this video. I'll see you in the next video. Thanks.